Folks, hello and welcome to Week 8. This is going to be our last major effort in Desmos since next week during Week 9 we will be back in the final exam mode, and we'll have a discussion board similar to what we had during Week 5, that being a sort of a homework discussion board where we can discuss whatever sorts of problems that you want from the homework and anything else to prepare for the exam. Last week, we began to tie together this idea of differentiation and integration, and this will be sort of that capstone idea this week that we will investigate through Desmos. So what I want to do before, there's a lot of Desmos work this week, and I want to make sure that we get through that in this video. Let me just start by going to the statement of the discussion post this week. So if we look at line 2 in Desmos, using the graph of the first derivative function you created in discussion 6, we're going to compute 3 separate definite integrals. As a reminder, this is going to look very much like the notation that you had for computing an antiderivative. It is the same notation, but what we are going to have now is lower and upper bounds, meaning that we are going to compute net signed area on an interval from a lower bound to an upper bound, which we will define for each one of these scenarios presented here. I'll talk a little bit about that net signed area idea when we get our first graph going here. But what I want to do now is let's flip back over to Desmos, and my week 6 base function was x to the 4th divided by x to the 4th plus 1. I'm just going to graph that using a domain from or positive numbers greater than, or I should say all real numbers greater than or equal to 0. I'll just turn that on here for the heck of it. So it's this function looks like it begins to increase and then it becomes asymptotic. It looks to be around y equals 1. And let's see, lines 3 and 4. Let's hold off on those. I'll explain the value of those lines after we get some of the integration done. What I want to do again is I want the first derivative of this function. So notice in line 6, I'm going to let g of x be the first derivative of f of x. And if I turn that on, the shape of that obviously makes sense based on looking at my base function here. The value of the first derivative is in fact greater than 0 for the entire function. So there's nothing peculiar about that. So going back to the statement of the discussion post, what we want to do now is we want to go through and we want to compute these 3 definite integrals based on some different lower and upper bounds for each. So the first one is asking us to find the value of the definite integral from a equals 0 to some value b that is greater than 0. So if we go back to Desmos here, definite integral with a equals 0 and b greater than a. This is integral 1, a1 to b1. And what I am able to do now is just define these based on sliding the values of a and b. So we want a to be 0, and we can pick some value for b. I don't know, we'll call it 4.5. So what we're saying here, let me do one other thing here before I start talking about area. Notice that we've got a couple steps here: x equals a1, x equals b1 for these values. The purpose of that is to infuse a1 and b1 to allow us to show the area under the curve and show it with shading. And so if I click on line 13, what that allows me to do is graph where the value of the function is greater than 0, meaning above the x-axis, and that's on an interval from 0 to 4.5. Actually, let me go a little tighter back in this direction. That way we can make sure we're clear. Let's go up to 2. You can see how this is kind of moving around here as I adjust 2. So this is the graph of the first derivative. And what we're doing is we're evaluating the total area under the curve from 0 to 2. And you'll get a value for that. Let me not forget to if I take a look at that and I go back up here and look at f of b1 minus f of a1 of the base function, it just so happens that these two values are equal. So you want to think about that when you explain this in terms of your scenario. If you recall, when I talked about the definite integral, I said what the definite integral computes is net signed area. What net signed area would be is the total amount of area bounded by the curve in the x-axis above the x-axis, subtracting from that any area that would be below the x-axis. So the difference between those two, if that value happened to be positive, it would mean there is more area bounded above the x-axis than there is below the x-axis. Because this function is not zero, or is not less than zero on this interval, when I turn on the shading for this bottom piece here, which would give me the area below the x-axis, you see nothing is shaded. But that's the idea of net signed area. So I'll turn that off, turn that back on just one more time. And again, as I adjust the value of the b, you can watch the function over here. So this is kind of neat, and it'll show you exactly what's being evaluated here. The second integral that I want to evaluate is, the only thing we're going to change here is we're going to let a be greater than 0. And let's go to that second set here. Definite integral with any two positive non-zero limits. And let's see what we've chosen here. Let's choose, I don't know, about 0.5. We don't want to go as far as 7. That's not going to show us much. Let's go to about 2.5 ought to be good. And then we'll turn on the shading again for the portion of where the function is above the x-axis. And again, this will shade again from a2 to b2, and it'll give us a value of the definite integral. And one more time, if you want to go back up here and take a look at f of b2 minus f of a2, notice that you have some commonality in that numerical value. And then finally, the last integral here you want is from 0 to positive infinity. Let me turn off the shading here. So this would shade your entire first derivative from 0 to infinity. Notice the value that you are getting for that. So let's see, I don't think I need this on. This is not going to change the graph. There's nothing below the x-axis. So this is, again, folks, this is really the capstone for everything that we have done from week 1 to week 8. And again, thinking about this in terms of your scenario. So again, go back and refresh in your mind what you use for a scenario during week 6. And what we want to be able to extract this week is after we look at that base function, the first derivative, and then we start looking at area under the curve of that first derivative, what does that tell us is going on in our scenario? And that's really, like I said, that is the capstone for the week. That is the ultimate goal. So I will look forward to seeing these discussion posts on the board. I hope the tutorial is helpful in terms of how to get the best use out of Desmos to help you to sort of correlate in your mind everything that's going on here with the base function, the first derivative, and then the area under the curve of the derivative on certain intervals. So again, have a great week. Let me know if there's anything I can do for you. And again, thanks for all the great work up through week 8.